Good evening, friends, and welcome back to day 6 of domain analytics as we continue to focus on securities, financial securities. So, today we'll be taking a look at decision tree classifier. Now, what is decision tree? A decision tree, let's say, for example, you run a hedge fund. Now, hedge fund is responsible for investing money. It is responsible for managing portfolios. So hedge funds tend to make large scale investments. All right. So let's say you have to make some capital investment. Now you're trying to decide how much capital investment you need to make. So you have various options with which you can make these investments, right? So let's say we start off here and we'll continue branching off into different fields. Okay. So decision one here was investment. So now that we have decided that we want to make this investment, we can decide on the sector we want to invest in. Are you looking to invest in a public sector or are you looking to invest in a private sector? Within those two sectors, which specific industry are you focusing on? Now, let's say, for example, you notice that oil barrels are getting cheaper. So what's happening here? What's happening here is that oil prices are dropping. So what can we expect here? We can expect that stock price for oil companies to go down as well. Okay, so we are expecting these stocks to go down. Now, oil is an interesting topic that we can discuss about, because oil industry, oil is basically a necessity in modern day life. We all have vehicles. We all have four-wheelers, two-wheelers. Here, a lot of people are reliant on oil for their businesses, right? You have all these public sector buses running on oil, right? So most of the world, I would say, you'll struggle to find parts of the world, at least where you have some semblance of development, that are not completely oil dependent. So even if the oil price is going high, even if the oil price is rising a lot, you can continue to expect people to keep buying oil. So when you have oil barrel price going high, the profits for these oil companies are also going high. So, but even with the increase in price, you don't really see that decrease in demand. Maybe you'll see some people saying that we'll switch over to public vehicles or public transport, but most people will continue on with their daily habits. Most people will continue to travel by car, right? Most people will continue to put oil in their petrol in their bikes. So this thing, it will keep happening. So oil is something, due to it being necessity, you can expect there to be significant demand even when the price is rising very high. We have seen the scenario right now where the oil price in a lot of places is soaring. But again, the price of oil being high doesn't mean that people will stop consuming it, right? So let's say we have two sectors, you have oil and you have renewable energy. Now, renewable energy, when oil price is cheaper, You can expect people to focus even more on oil, to purchase more oil than they would have purchased if the price was standard. So with the decrease in price, the demand is going up, but at the same time, the price for these companies are going down. Similarly, you can expect the price, the stocks, the shares of these renewable related companies to also decrease. Okay. So if you're trying to make some investment in it, you have to decide whether you want to go with oil or you want to go with renewable energy. So let's look at it in a different manner. Let's look at this tree in a different manner. So the sector you're choosing here, let's say you have energy and you have some other sector, let's say defense. Which sector do you invest in? Now, if you are in the US, defense is a very good industry to make money out of. Plenty of people have done that all their lives. But now, if there is no ongoing war, for example, now that America is completely out of any conflict in Asia, they don't have any sort of mass war going on where you can expect the defense spending to keep rising. Obviously, that doesn't mean that the spendings will stop completely. It just means that they will reduce a little bit. So let's say you decide on going with energy sector. So this defense sector, it ends right here. You are not going further with this. What you're doing here is, now you have two options. You have oil, you have renewable. Next thing maybe you're taking a look at is, you're saying that oil is going to give us more profit because the stock price is low. If we invest in it now, once the stock price rises, the return of investment, the ROI would be higher with oil. So you're switching to oil. Now here, you're looking at different companies. You have segmented your sector into two portions, and then you have segmented that sector, specific sector portion of the sector you have selected into different companies. Okay. So here, what we do is, let's say you have Aramco, you have Gulf Oil, and maybe you have BP, Bharat Petroleum. Next thing you're taking a look at is how much profit you're gaining, how much expected profit you are gaining by making these investments. You're taking a look at historical records. So based off of that, you can say that the profit here was 7 million. If you invest, let's say our investment is 5 million. You're investing 5 million USD. Here it is 7. Here it is, what do you call it? 8. And here it is 6. So based off of this branch, based off of this tree, you can say that we will select Gulf Oil for expanding our portfolio. So that is what a decision tree is. A decision tree is nothing but a tree-like structure. This tree-like structure is going to help you make some decisions. Okay. And based off of those decisions, you can decide what is your best output. Now, this decision tree classifier falls under supervised learning. Now here, it means that your why is known. So here, most likely, we knew the profits for all these. We can say that in defense, if you invest 5 million right now, you'll get 5.5 million return in your time frame. Here, you will actually end up making a loss. So you know how much money you're likely to get back. You have done those predictions as well. So based off of this, you decide Gulf Oil is the best to put 5 million in. So our output here was profit, and the profit is known. All right. So we can use either discrete values and we can use continuous values. So we'll take a look at decision tree classification model as well as the hands-on on how this works in real life. So decision tree is a tree-like structure. All right. A decision tree is a tree-like structure. So basically it is replicating any tree. Now, if you have planted a tree, you start off with the root. You plant the roots first. Obviously, there might be some trees that don't, I am not familiar with any trees that don't require any sort of roots. But again, it's a tree-like structure. So you start off with the root. This root node is where all the magic begins. Then you get these branches. When a tree starts growing, it will start getting some branches. These branches represent the different decisions available to you. Now, let's say within this branch, you segment this into further 3 branches each. But here you don't. Here you cannot make any further segmentation based on the attributes. So this is called your leaf node. Leaf node is where your decision tree cannot be segmented any further. And these are what we call as branch nodes. So whenever you have a node segmenting into further nodes, it is called a branch node. And any decision tree that you will ever build will be built off of this root node. This root node is where everything begins. So how do we start? How do we start? First, we try to specify this root node. The specification of this root node is very important. Without figuring out what a root node is, we cannot proceed further. Now, these are called internal nodes, but we can also call them as branch nodes. So here, what we are trying to do is we are trying to find the root node, and based off of that, we are segmenting a tree further and further based on the attributes. Okay. So let's say one minute. So this is what a decision tree looks like. So here we have some data set. We are looking at whether a person is going to buy a laptop or not. Okay, so we have an attribute called student. This would be a root node. This node defines where rest of the segmentation is done. So based off of this root node, this attribute had binary output, yes or no. So based off of that, we split it into 2 separate branches. We split it into 2 separate branches. So the first branch we get is what we call as income. So we have income, and with this income, you have 3 possible outputs: low, medium, and high. What this means is the salary can be low, medium, or high. But here we notice that when a person is not a student, their salary can only be high or medium. Okay. So what this means is that we split this specific income node into high and medium only. We don't have anything for low. Nothing is there for low in the data set. So we split it. But when a person is student, they can be either high, medium, and low. They can be belonging to any of these three income groups. So we split this into three. Now here you might notice when the person's salary is medium, yes, they are going to buy the laptop. So this specific branch, starting from student, yes, income, medium, is saying that the person is going to buy the laptop. Similarly, if your student, yes, and your income is high, yes, you will buy the laptop. So here we have two branches coming to an end. So these two yes values are what we call as leaf node or terminal node. So we have terminated our decision making at this point. Okay. So then once that is done, then we move on to the next one. The next one is what we call as credit rating. This is for income low. If your if your income is high, we are going to the age factor. If your age is less than 30, you will not buy a laptop. If your age is between 31 and 40, you will buy a laptop. So again, this is where our decision tree comes to an end for this specific branch. Similarly, here, this is also coming to an end. So we have created 4 decisions so far. Then we move on to income medium. Then we are taking a look at credit rating. If the credit rating is fair, then we go here. If your age is greater than 40, yes, you will buy the laptop. If it is less than 30, you will not buy a laptop. So we have made 2 more decisions. If your credit rating is excellent and your age is greater than 40, no, you will not buy a laptop. And if it is between 31 to 40, yes, you will buy a laptop. So we have made 2 more decisions. So finally, the only branch we are left with is income low. When income is low, we check the credit rating. If the credit rating is fair, yes, you buy the laptop. If the credit rating is excellent and you're between 31 to 40, yes, you will buy the laptop. And if you are greater than 40, no, you will not buy the laptop. So this is how a decision tree is formed. This is how we make decisions using decision tree. Now here we can summarize these rules. So we see we are starting off with student no. We are going to income high and we are saying that age is less than 30, then they will not buy a laptop. If the age is between 31 and 40 for income high and student no, then they will buy a laptop. Okay. So this is a bunch of decisions using the data set we were given that we have made. So similarly, you can use income. We have seen that income can be of 3 types: low, medium, and high. So we split it based on that. If your income is high and your age is less than 30, then you will not buy a laptop. If it is between 31 and 40, then you will buy a laptop. So we have made 2 decisions just in this. If your income is medium and you are a student, you will buy a laptop. Another decision made. And if you're not a student, then we split into age and then we split into credit rating. And if your income is low, then we directly go to credit rating and then we go to age. So here in the second level, we have 3 different attributes for each of these values. We are just not focusing on one thing. All right. We are trying to reduce the complexity of our decision tree, and we are trying to find out how many rules we can form. Now, more rules are not better here. More rules mean more chance of error. So we are trying to reduce these errors. All right. So in order to reduce these errors, we try to reduce the complexity. Okay. Then again, we get a bunch of rules. This time we got 10 rules. Last time we got 11 rules. So here, what we are trying to do is we are trying to find information gain. How much information we are looking at information gain. So this information gain is going to decide the structure of our decision tree. This information gain decides the structure of a decision tree. Okay. So what we are doing here is we are taking highest information gain as a root node. Whichever attribute is giving us the highest information gain, we are taking that as a root node. So what this means is that we are trying to take the most possible information and we are going after that. So for that, we are using entropy. Entropy means how much loss is going to be there. Okay. So we are taking entropy and we are using this formula. Information gained on D. So we are taking all the attributes here, finding the information gain. And then what we are doing is we are finding after we split, after using A, our attribute A to split into number of V div partitions. These D stands for decisions. How many ever partitions you're splitting, this is how your information gain formula is given as. Okay. And then finally, we are trying to find the gain. The gain is information given by D minus the information given when you split A into D partitions. Okay. So this was our data set. So now let's take a look at the data set. So we have various columns. This is record. This is our index column. And these are our attributes. Now these four, age, income, student, and credit rating are our X variables. This means these variables are independent. Again, another basic concept for supervised machine learning that we have covered before. And Bayes computer is a Y variable, which means this is our dependent variable. Okay. So this Y computer depends on all these inputs. And we have already seen when we have taken income and student as our attributes, we have gotten 11 rules and 10 rules respectively. And this is just from 14 records. Just from 14 records, we are getting 10 possible rules and 11 possible rules. So what we try to do is we try to reduce the complexity of our decision tree. And in order to reduce the complexity, we use information gain. So here we had two possible outputs, yes or no. So first thing we do is we try to find the probability of all our outputs. We try to find the probability of all our outputs. If they are buying yes, then the probability is 9/14. If they are saying no, then the probability is 5/14. Then we calculate the initial information gain. Okay, then we calculate the initial information gain. So you take the probability, that is 9/14, and you take log base 2 of that probability. Okay, so you take probability times log base 2 of that probability, and then you subtract it from your other possible output, that is no. Again, you're taking the probability and then you're subtracting it from log 2 of the probability. So the entropy in this scenario is 0.940. Now similarly, now let's say we want to split it. Now we have seen we have 4 possible outputs, right? So we start off with the first one. The first attribute we have is age. Okay. So the first attribute we have is age. So we have 2 possible options. We have positive and negative. Okay. So you find out the probability of having age positive. You take the second root of log, and then you subtract it from the probability of having negative, and you subtract it from the second root of log. So I think we can probably try this. Let's say we'll go to our friends over at Wolfram Alpha. So we'll say we say 2/5 times this the log base 2/5 minus 2/5 times log base 2. Sorry, this would be 3/5, right? Yes, 3/5. 3/5. And then we calculate our answer. So wait, I think it should be 2/14. It should be 2/14 because we have 14 possible outcomes. So the output we are getting here would be 0.971 and 0.971 because they are the same. But when you have only one attribute, this value, I value, information gain value is 0. So then we calculate the information gained for age, and the final output is 0.694. So we subtract this information gain, the overall information gain minus this information gained on age. So if you use age as your root node, this is how much information you are gaining. Okay, so that is how we calculate information gain. Then moving forward. So taking age as the attribute, we can see that we end up with 5 possible rules. So we get, if age is less than 30 and they are not a student, they will not buy the laptop. All right. Similarly, if age is less than 30 but they are a student, they will buy the laptop. If age is between 30 and 40, yes, they will buy the laptop. If age is greater than 40 and credit rating is excellent, then they will not buy the laptop. If age is greater than 40 and the credit rating is fair, yes, they will buy the laptop. So now we have reduced the number of possible rules to 5 rules. So we have done what? We have done reduced complexity. And with this reduced complexity, we can proceed further. All right. So this is how you make a decision on how many attributes you want to go for. Now, decision tree has some disadvantages. This is a small change in data can cause a lot of issues. Okay. And second of all, it is not very suitable for larger data sets, because the complexity is going to get so high that you'll not be able to make good decisions. All right. So let's take a look at an use case and try to understand it. Okay, let me just pull up the codes. Okay, so now that we have our data set, first we'll do our basic libraries, NumPy, Pandas, Seaborn, Matplotlib, etc., whatever we need. So we import the libraries and then we import the data set. So first, let's spend a few minutes to understand what is going on in our data set. So here we have, again, we are continuing on focus on money laundering. So yeah, last time we took a look at KNN, and we were taking a look at a fairly simple data set to predict money laundering. Now we are going further on, and we are trying to use their transactions. Again, we are focusing on the transactions. So using these transactions, we are trying to predict if they committed fraud or not. Are they laundering some money or not? So the attributes we have are the total amount. How much amount are they depositing? This is in the thousands. Then you have how many times have they done any transactions over the weekend. Okay. And then you have how many transactions have they done any transactions during the night. So these two are Boolean output, yes or no. One means yes, zero means no. How many transactions are they doing in a 1 day window? How many transactions they are doing in a 7-day window? And similarly, how many transactions they are doing in a 30-day window? And then you're taking a look at what is their average amount for a 1 day window, 7-day window, and a 30-day window. So now instead of focusing on only our how much money they have transferred, we are trying to segment the transfers into different portions. We are trying to see if transactions done at night or at weekend mean anything. We are trying to see total number of transactions. To see if anything possible is there. All right. So then we have the terminal ID. How many terminals are they accessing in a 1 day window? How many terminals, different branches, different banks are they accessing in a 7-day window? And again, how many terminals they are accessing in a 30-day window? And then what we have done here is we are given some risk rating. That means the terminals they are accessing from point 1 to point 2, money is moving somewhere. Now, from where they're moving money to where it is being moved, is there any sort of financial risk associated with it? Okay. So let's say, for example, if you Liechtenstein or something like that, I forgot the name, Liechtenstein, it's a small kingdom type of country that is right next to Switzerland. Now, the point about Liechtenstein is it has very strong privacy rules, especially when it comes to banks. And it also has no questions asked rules. So basically, you can deposit anything within this country and nobody will question you. Nobody will care what's your source. Nobody will ask you to get some documentation. They only care about the funds coming into their banks. So what we try to do here is using this Liechtenstein, this would have a higher risk rating than compared to countries with more stringent financial laws like France or USA or even India, especially when it comes to bank transaction, where you cannot simply just send your illegally earned money from one account to another. You have to do some whitewashing. Then that whitewashing is something we are trying to predict. So what we are trying to do here is we are trying to see if they access terminals within a 1-day window, how much risk is associated with different terminals ID for a 7-day. This is 1 day, this is 7-day, and this is 30 days. So you're trying to find out the risk probability associated with each of these terminal IDs. So here we have some risk factors. We have some values that are depicting the risk. And finally, we have a column that is saying that fraud was committed or not. And this is again binary output. So this is our data set. And this is the use case that we are working with. So again, the first 5 rows, you have the text, you have the data types, all of them are numeric except for the output that is discrete. So when you have discrete output, it becomes a classification problem. So here you're trying to make some sort of classification. All right. So then moving forward, we check if we have any non-null values. So we can see that we are dealing with a huge data set. So we have sufficient data set for making our predictions. So we just calculate the mean, mode, median, anything. We can also take a look at the correlation heat map. So you can see that we don't have a problem of correlation. We don't have a high degree of correlation. Okay. So then we check for unique values, yes and no. And then we see that the split is almost even. It's a 2/3 split. So no is dominating, but we have sufficient yes values as well. So what we'll do is we'll split our column into different values. So these are our column names. So what we'll do is we'll create target values and we will create predictors. So these target values and these predictor values, they are a X and Y variable. What we are doing here is instead of specifying the column names, we are saying that search these column names and wherever these column names match, you can consider that as a decision tree. Okay. So then let's see. After doing that, we do the train test split. Standard procedure. We can also check the shape just to ensure that everything is matching up. We don't have X and Y variables here because we don't need to get into that. We have just train and test. Okay. So again, same number of attributes. So you have 16 attributes in total that we are taking a look at. So then what we'll do is we'll use sklearn. Sklearn again contains our model. And here we are using decision tree classifier. Okay. So using this decision tree classifier, we can build our model. So here we have to specify the criteria we are taking, and the criteria we are taking is entropy. So using entropy, build it. We fit our model on test and train. So now our test and train data, now our train data is again trained. So what we do is we check for training accuracy. So here we have our confusion matrix. This confusion matrix contains this confusion metric is going to tell us if how many false positive and false negative values we are getting. And we can check the accuracy score. The accuracy score is 96%. Similarly, we should also check the test accuracy. Sorry, the train accuracy, to see if our training accuracy is sufficiently good or not. So let's add code. Okay, could not convert string to float. Mistake we make. Predict. Here we have to predict using a predictors. We have to specify the predictors and it will make some predictions based off of that. So here we can see that we are getting 100% accuracy. So that means at least in this scenario, a model is a great fit for prediction of, for classification of transactions into classification of transactions into whether they are fraud or not. Of course, you can try out different things. You can try out different test and train size. So if I change this to, let's say, 0.3, it might make some difference. So it has reduced the accuracy a little bit. But at the end of the day, we are trying to find the best possible accuracy. Similarly, in this, we can also try cross-validation, where you can take different parameters and try to build a decision tree accordingly. And that should give you the output. Now, finally, we can also visualize this decision tree. But let me show you why we probably won't be doing that. So now it has started visualizing the decision tree. So here you can see these are all the possible decisions that it could be making. So here you can see the number of decisions you're making is huge and it is still calculating. So let's just wait for it to quickly calculate. Once that's done, we'll visualize our decision tree. So we have seen decision tree and we have seen how we can use it for our purpose. We have seen how we can apply decision tree in classification problems, how we can classify our output into different values. All right. So this is what the decision tree looks like. Again, you can see it's quite a complex decision tree. And based off of this, our model has made the decisions. It has gone through all the possible combinations and it has tried to build the best possible tree. So again, if you have a lot of if your data set is huge, you might run into some issues with this. But again, until and unless you build a model, you'll not know if you'll get those issues or not. So that is it. With this, we finish decision tree. And again, we'll meet tomorrow. So thank you everyone for joining.